The sun is amazing. It's a giant ball of hot gas. And guess what? It gives off a tremendous amount of energy. In just 1 hour, the sun produces more energy than the entire world uses in a year. Let's explore how the sun creates this incredible power and how we can harness it right here on Earth. The sun's energy is the source of life as we know it. It provides light and warmth. It powers our weather patterns. It even helps plants grow. Without the sun, our planet would be a very different place. So how does the sun make all this energy? It's a fascinating process that powers not just our solar system, but also provides the energy we harness here on Earth. The answer is a process called nuclear fusion. This is the same process that powers hydrogen bombs, but on a much grander and controlled scale. Deep inside the sun's core, it's incredibly hot and dense. Temperatures soar to millions of degrees, creating an environment where extraordinary reactions can occur. Think about the most intense heat you can imagine, and then multiply it by 1,000,000. This unimaginable heat is crucial for the fusion process. Under these extreme conditions, tiny particles called atoms smash together. This collision is so powerful that it overcomes the natural repulsion between the positively charged nuclei. The sun is mostly made of hydrogen, the simplest and lightest atom. Hydrogen atoms are the primary fuel for the sun's energy production. In the core, hydrogen atoms are forced together with so much pressure that they fuse or combine to form helium, the second lightest atom. This fusion process is the heart of the sun's energy production. This fusion process releases an enormous amount of energy in the form of light and heat. This energy radiates out from the sun, providing the warmth and light that sustain life on Earth. This energy from the sun doesn't just stay put, it travels through space at the speed of light, which is incredibly fast. Light is a form of electromagnetic radiation. This radiation travels in waves. These waves have different lengths, and the different lengths make up what we call the electromagnetic spectrum. The visible light we see is just a small part of the spectrum, but it's an important part, especially for solar energy. Solar panels are designed to capture this visible light and put it to work. Solar panels. Capturing the sun's power. Solar panels are like high-tech sunbathers, soaking up the sun's rays to generate electricity. They're made up of smaller units called photovoltaic cells, usually made from silicon. These cells are the heart of the solar panel. When sunlight hits these cells, something amazing happens. The energy from the sun is converted into electrical energy. Remember those tiny particles called atoms? They are the building blocks of everything around us. Well, light is made up of even tinier packets of energy called photons. These photons carry the sun's energy to the solar panels. When a photon from sunlight hits the silicon in a solar cell, it knocks an electron loose from a silicon atom. This is the start of electricity generation. This creates a flow of electrons, which is what electricity is. The movement of these electrons through a circuit generates power. The more sunlight hits the panel, the more electrons flow and the more electricity is generated. This is how we capture the sun's power to light up our world. Storing sunshine. Using solar energy today and tomorrow. Solar panels are great at generating electricity from sunlight. They capture the sun's rays and convert them into usable electricity, which can power everything from small gadgets to entire homes. But what happens when the sun goes down or if it's cloudy? Solar panels can't generate electricity without sunlight, which poses a challenge for consistent energy supply. That's where energy storage comes in. By storing the excess energy generated during sunny periods, we can ensure a steady supply of electricity even when the sun isn't shining. We can store the electricity generated by solar panels in batteries. These batteries act as a reservoir, holding on to the energy until it's needed. These batteries can then power our homes and businesses even when the sun isn't shining. This means that solar energy can be a reliable source of power around the clock. We can also send the electricity from solar panels to a power grid. This allows for the distribution of solar energy on a much larger scale. This grid is like a giant network of wires that distributes electricity. It ensures that the energy generated by solar panels can reach homes and businesses far and wide. By feeding solar energy into the grid, we can use it to power entire communities. This not only reduces our reliance on fossil fuels, but also promotes a cleaner environment. Scientists and engineers are constantly working to improve solar technology. Their innovations are making solar panels more efficient and cost-effective. They're making solar panels more efficient at converting sunlight into electricity. This means we can generate more power from the same amount of sunlight. They're also developing new ways to store solar energy and use it in even more innovative ways. From advanced battery systems to new materials, the future of solar energy is bright. The sun is a powerful source of energy, and we're only beginning to tap into its potential. With continued research and development, the possibilities are endless. By harnessing the power of the sun, we can create a cleaner, more sustainable future for generations to come. Solar energy is not just a solution for today, but a promise for tomorrow. Who knows what amazing solar-powered inventions we'll come up with next? The future of solar energy is full of exciting possibilities, and we're just getting started. Do you think solar energy is the future? Let us know in the comments.